This is Mr. TG. This is part 2 of lesson 2.3 or 2-3 on linear functions and slope-intercept form. What we're going to do in this video is we're going to define, first of all, what a linear function is. As you can see from the guided notes, a linear function right here is an equation that represents a line when you graph it. Very simple definition. If I graph a function and it forms a line, we call it linear. Um, we like to have our linear functions in special forms, and it makes it easier to graph. It makes it easier to do a lot of different things. One of those forms is called slope-intercept form. Slope-intercept form is y equals mx plus b. And it simply means that our equation is solved for y. If our equation is solved for y, then we know the slope, which is the m, and this is called the y-intercept. So we know two components. Again, if the equation is solved for y, the m represents the slope, and that's the steepness of the line. The y-intercept b is called the y-intercept. Now this basically is where the line crosses the y-axis, not the x-axis, but the y-axis. So to show you an example here, let's take a look at this. Right away, I see that it's solved for y, so I know it's in slope-intercept form. I've got the slope here and the y-intercept here. Just remember, the slope does not include the variable x, it's just 1/3. So we'll identify that as a slope, 1/3, and then the y-intercept's -4. So it's very easy to identify the slope and the y-intercept once you have it in slope-intercept form. So the slope is 1/3 and the y-intercept's -4. Now we will ask you to graph these functions. So here's what you do first. You always start on your y-axis. Where is your y-intercept? And as you can see, it's located at a -4. That corresponds with our y-intercept. So I'll plot a point there. Don't go on the x, go on the y-axis. And then what you simply do is from that point you plot a series of points that will represent a slope of 1/3. So we would go up 1 and over 3, and we're going this way because we want this slope to be positive. And you can plot as many points as you like, up 1 and over 3. And if you want to go backwards, that's fine. You go down 1 and go left 3. But as you can see here, the points will form a straight line, as they should, since this is a linear function. There's your line graph of the equation. Now, the last lesson we had you graph by plotting points. That is another way of doing that. But this particular method of graphing equations that are in slope-intercept form is a shortcut. It allows you to identify the slope and y-intercept quickly and efficiently find where those points are on the line by plotting the slope. The next one, as you can see, problem number 2, let's erase what we have here so far. Problem number 2, as you can see, is not in slope-intercept form. So we're going to have to do some work with this one. This is not solved for y. So if you need to find the slope and the y-intercept, you first must solve for y. So let's go ahead and show how that's done. The first thing we're going to do, let's write the equation out because this involves a little bit of work. So I got 5x minus 4y equals 16. We're going to solve this equation for y, and the first step in doing that is to subtract 5x from both sides. We're going to subtract 5x, and when we do solve for y, it's like solving a literal equation. You're not actually going to get an answer. You're just going to get another form of the equation. So we end up with -4y is equal to a -5x plus 16. Then, as you can see, we have multiplication to undo, so we're going to divide by a -4. And that's going to give us y is equal to positive 5/4 x, and notice this is going to be my slope. Notice the fraction here doesn't work out. Don't change it to a decimal. Just leave it as a fraction and reduce it. There are two negatives here, so we know a negative divided by a negative is positive. So that's the only thing I really did with this, is change it to a positive slope, which is what it is. And then plus a negative 4. Now, basically, you have your equation now, and this is the same form as the first one. The toughest part about this is that getting it solved for y. But now, again, as you can see, we can start at negative 4, because that's our y-intercept. Always start at your y-intercept. Go up 1, 2, 3, 4, 5, and then count over 1, 2, 3, 4. There would be your next point. Let's see if I counted right. You got a rise of 1, 2, 3, 4, 5, and then 1, 2, 3, 4. And then you can continue doing that. 1, 2, 3, 4, 5 over 1, 2, 3, 4. It gives you a couple points of the graph, and there is your line. So hopefully that made sense. And if we identified the slope up here, it would be 5/4, and the y-intercept would be a negative 4. Now, what I'm going to do here is erase. I want to make up the problem and have you try it. Let me erase what I've got here so far. And you can obviously use your notes to do this, but let's erase all this. And let's put in a new equation. This one I'm going to write as x minus 2y equals 2. So what I would like to have you do is first find the slope of this equation. And we'll put this up here because we got some work to do here. And the y-intercept. Find both of those. And then graph it on one of the two grids provided. So I'll give you a little bit of time to do that, and we'll check your work. Welcome back. Hopefully you were successful. So if we're looking at this equation, it is not solved for y, so we have to first solve it for y, and that's probably going to be where you're going to have most of your difficulties. And again, it's like solving a literal equation. So what we're going to do first is subtract x from both sides, and that will give us a negative 2y equals negative x plus 2. Then we're going to divide by a negative 2, and that's going to give us y equals 1/2 x plus a negative 1. All right, now as you can see, it's solved for y. We have our slope, because now it's in slope-intercept form, and we have our y-intercept. To graph this, you would start at negative 1. You would then go up 1 over 2, up 1 over 2, plot the points, connect them, and there's your line. So changing it to slope-intercept form and then graphing it. Now, the only thing I did not show you is all these lines turned out to have a positive slope. Let me show you how I graph negative slopes. If I have slope-intercept form and it looks like this, let's just make one up, negative 3x. Let's say we're going to graph this equation. Here's another equation. It's already in slope-intercept form. There is no number over here, so if you want, you can put a plus 0 over here. That 0 is your y-intercept. So our slope becomes negative 3, and our y-intercept is 0. So how would you graph that? I'll graph it on the first grid. You would plot 0, 0. This one's going to cross the origin. Now, since our slope is negative, we know that's going to go downhill. You can do this one of two ways. You can go down 3 and over 1, because we all know that this is the same thing as negative 3 over 1. Or you can go up 3 and left 1. Just make sure that your slope of your line is going that you're going downhill. So you're going from your upper left down to your lower right. So that's another trick of the trade as far as graphing equations with negative slopes. So that completes our lesson on slope-intercept form, equations that are in slope-intercept form. Hopefully that went well.